In this video, we'll look at how the Nix ID consistency model and the InfiniteTalk lip sync model are integrated into the updated VCE workflow, which uses 8-frame overlap and allows unlimited length video conversion. In the previous video, we discussed that the Nix model is an extremely versatile model. It can be integrated into our workflow from any perspective. The lip syncing in InfiniteTalk is also plug and play. It might be possible to connect this location with UNE3C as well. This process is mainly for reference and learning, with sharing as the focus. It does not guarantee that every result will be good. Now let's look at the workflow. I'm using RunningHub, the largest online rehabilitation AI platform globally. It starts up quickly. Let's set the maximum size constraint for the longest edge. Since it's proportional scaling, both dimensions will be the same, such as 1280x720 or 848x480 and so on. Set prompts, load reference images, load extracted pose videos, and load audio. If the number of loops is n, then the total number of frames equals n multiplied by 73. Add 81 and then round up to find the value of n. Model parts include mixed model, InfiniteTalk model, VACE model, 121's T2V model, and accelerated LoRA HPS level. To make this process work smoothly, it mainly depends on using these two nodes, the mixed model and the VAC model, combined together with InfiniteTalk part placed at the bottom. All of the loaded videos and generated video frames are locked at 25 frames per second to ensure greater consistency. Let's hear the result.
That American guy is so strange. He rushed up to me as soon as he walked in and insisted I marry him.
Oh, this definitely works here. It depends on our cost and the proportion of the frame it occupies. Navigate to RunningHub, click on AI, or click the link in the introduction to register, and you'll receive 1,200 points. Logging in daily will give you an additional 100 points. The corresponding AI workflow and one-click AI applications have been deployed online and can now be run and tested online. Then we'll look at the techniques used in building this. The process is still divided into two parts. The left side is used for initial generation with 80 billion frames just to see what the first result looks like. If the first result is somewhat acceptable, we can then proceed to generate longer videos with more iterations. The loop portion works the same way as before, overlapping 8 frames to send the last 8 frames of each segment into the VACE's start and end frame nodes as the initial frame. This way, by looking at the context, we can easily and with high probability guide the generation of our next video segment. We tested it before, even without adding new technologies, its consistency is very strong. Adding Nix's technology would be like adding flowers to a painted scroll. Moreover, Nix's technology has already explained that the reference image feature refers to parts other than the face. Essentially, during each cycle of rendering, it emphasizes the general state of the head. So through multiple cycles of processing in batches of 81 frames, the loss can be kept very low. By nature, the degree of damage to the face, head, and facial area should be extremely minimal. So if the similarity drops, it should be because of something else, like clothing. Here, I used pose videos to guide the video generation. To avoid extracting too many pose videos during the initial loop, I adopted the method of loading the original video multiple times. This way, by using simple mathematical expressions, you can achieve an initial render at 81 frames and subsequent renders also at 81 frames. However, in the end, we will drop 8 frames, so during each cycle, the number of useful frames in each batch is only 73. This place has been tested many times. If there were any issues, they should have shown up long ago. Everything we have is looping, and the audio we load is also looping. This should be an 18-second audio clip. If the generation is excellent, we only need 3 minutes and 24 seconds. So we take that portion, 81 divided by 25 equals 3 minutes and 24 seconds. Not every node is as precise as this ACE node, so finding it isn't always easy. The numbers before the colon are seconds, the middle ones are frames, and the 3 zeros after represent milliseconds. Every 1,000 milliseconds equals 1 second. It's a base 60 system, but I'm not very familiar with audio. That's roughly how it works. So the symbol right here is 3.24. The audio enters a loop. Each segment is 81 frames long, which equals 3.24 seconds. So A plus 3.24 means the end of the tail is at 3.24. Once we enter the loop, each batch will only produce 73 useful frames. Dividing 73 by 25 gives us 2.92. Then we use this value as an index increment. Initially, in the first iteration of the loop, it starts at 2.92. We can see that the previous segment ended here. 3.24 because there is an overlap of 0.32. Then subsequent increases can follow the rule of multiplying by 2.9 times 0.9. Finally, just merge them into one segment directly. There's no complicated explanation. This level of detailed calculation is done to ensure accuracy during each step of the reasoning process. In reality, the results didn't show much difference. So in the case of the Infinity token, KG used a similar approach before for looping, but now I'm doing it manually. Later, he naturally updated his approach, no longer needing to step out of potential space, which might still cause some issues. I think a mix of daily effort videos would be sufficient. So most of the time, this channel shares open source models and projects, but closed source models are where RunningHub really shines. He brought down the prices of many popular models, such as Video, Kaling, and Wanxiang. Some specifications were even lower than the official published prices. The more you use it, the more you'll realize that saving up bit by bit really saves money in the long run.